Okay, today we're going to be looking at geometric progressions. So, a geometric progression is something like the sequence 2, 6, 18, 54, and so on. This is an example of a geometric progression. Each term is 3 times the preceding term. So we've got 2, we times 3 to get 6. 6 times 3 is 18, and 18 times 3 is 54. So in a geometric progression we have a constant multiplier. And in this case it's 3, and that's called the common ratio. So the notation for the geometric progression is A, again, is the first term, just like we had with the arithmetic progression. And this time R is the common ratio. The first 5 terms of a geometric progression, where A is the first term and R is the common ratio, we've got A is the term 1, A times R is term 2. Now for the third term you would multiply this by R again, which gives us AR squared is term 3. So if you think next time you multiply that by R again, which would then give us AR cubed is term 4. Similarly, if you times this again by R, you get AR to the power 4 is going to be term 5. So we can see that the nth term is equal to the first term, A, times the common ratio raised to the power of n minus 1. Which we can see here, this is term 5, but we raise that r to the power 4, so n minus 1. So let's look at a few examples. So the fifth term of a geometric progression is 1, and the common ratio is half. Find the 8th term. And an expression for the nth term. So we know that nth term is equal to A, where A is the first term, R, n minus 1, where R is the common ratio. Now we know that the first term A is, we don't know what the first term A is. We know that the R is a half, and we know when n equals 5, the nth term equals 1. So 1 must equal whatever A is, which we don't know, times a half. Now the n is going to be raised to the power 5 minus 1, which is a half raised to the power 4, which is A multiplied by 1/16 So A must be 16. So this gives us our expression for the nth term. Must be A, which is 16, times a half, which is our common difference, n minus 1. So that's our for the our term for the geometric progression for the nth term. Now we want to know what the 8th term is. So when n equals 8, the 8th term is going to be 16 times a half, and it's n minus 1, which is going to be 7. So working all that out, we will get an 8th. And for this kind of one, just leave it as a fraction because it's nice, it's tidier. The 2nd and 5th terms in a geometric progression are 12 and 40.5 respectively. Find the first term and the common ratio. Hence, find an expression for the nth term. Okay, so remember our general formula is the nth term is A R n minus 1. Now, just like we used for the arithmetic series, we can use information to have a couple of simultaneous equations that we can then solve our unknowns in. So we know for the second, for n equal to 2, the second term is 12 is equal to, we don't know what A is and we don't know what R is, and 2 minus 1 is just 1. And we know when n equals 5, the 5th term is equal to 40.5 is equal to A R. Now it's the 5th term, so 5 minus 1 is 4. Now we're going to call this equation 1 and we're going to call this equation 2. And what we're going to do this time, whereas with the arithmetic series we added them, this time we're going to divide. So we're going to take the second term and we're going to divide it by the first term. So we're going to have 40.5 over 12 must equal AR to the power 4 over AR. So as you can see, the A's are going to cancel, and then we're going to have A cubed. And resolving that, you'll end up with R is equal to root 3, 3 over 2, sorry. So now we substitute R into equation 1. So we have 12 is equal to A times 3 over 2. So that's going to give us A as 8. So our general term, the nth term is ARN minus 1, which is going to be 8 3 over 2 n minus 1. And next example, the nth term of a geometric progression is 9 multiplied by minus 2 over 3 raised to the power n. Find the first term and the common ratio. So the first term is equal to 9 minus 2 over 3 raised to the power 1, which, working that out, will just give us minus 6. The second term is 9 minus 2 over 3 raised to the power 2, which gives us 4. So the common ratio is equal to the second term over the first term. When we're finding the common ratio, remember it is the second term over the first term, not the first term over the second term. Just make sure you do it the right way round. Is going to be 4 over 6. Minus 6, which is going to give us minus 2 over 3. So our first term, which would be A, is equal to minus 6, and our common ratio which is R, is equal to minus 2 over 3. Now, just with the same as our arithmetic progression, we can find the sum of a geometric progression as well. And the sum of the geometric progression, Sn, can be written as A multiplied by 1 minus r to the n over 1 minus r, or Sn equals A r to the n minus 1 over r minus 1. Either formula can be used, but it's usually either to, so you'd use the first formula, so use f minus 1 is less than r is less than 1, and you use this one if r is greater than 1 or r is less than or equal to minus 1. Now it's important to have a handle on the proof for these. So this is the proof. So we know that Sn is equal to A plus AR plus AR squared plus AR cubed plus so on and so forth until we get to ARN minus 2 plus ARN minus 1. So this is equation 1. And then we're going to take Sn, now we're going to multiply it by r. So we've taken r times equation 1. So we'll get A is going to be AR plus AR squared plus AR cubed plus ARn minus 2 plus ARn minus 1 plus ARn. And that's equation 2. So we're now going to take equation 2 and minus equation 1. So we'll have RSN minus SN. So that's going to give us A R to the power n minus A. As you can see, these terms are all going to cancel out, so we're just going to be left with AR to the power n minus A. Now if we simplify this, so we're going to have r minus 1 multiplied by Sn, to put that into brackets, equals ARn minus A. So Sn must equal AR to the power n minus A over r minus 1, and we can simplify that as well, r minus 1, which is what we have up here. Now, here's a wee thing for you to think about. Why can't r equal 1? I'll give you a little hint. Think about down there. So let's have a couple of examples using these. Find the sum of the first 12 terms of the geometric progression (3 plus 6 plus 12 plus 24 plus all of these. So there's 3, 6, 12, 24 is our geometric progression. So we know that the sum of the geometric progression is A multiplied by r to the n minus 1 over r minus 1. Now for this one, A is the first term, and that's equal to 3. R is the common difference, so to get from the common ratio, is going to be 2, because 3 times 2 is 6, 6 times 2 is 12, 12 times 2 is 24. So we have 3, then we have, and we're using n is 12, so s of 12. R is 2 to the power 12 minus 1 over 2 minus 1. Plugging all that into your calculator, you're going to get 12,285. With these sums, with geometric progressions, you can often get very big numbers very quickly. The final example is going to be the third term of a geometric progression is 9 times the first term. The sum of the first 6 terms is k times the sum of the first two terms. Find the value of k. So, the third term is equal to 9 times the first term. And so and remember, for the geometric progression, we're using the nth term is AR to the n minus 1, because this is the geometric progression, not the sum of the terms. So for the third term, we've got AR and n minus 1 is going to be 2, and that's equal to 9 times the first term. So the first term is going to just be, it's going to be 9 times A, because the R term will, it's going to be n to the power 0, which is going to be 1, so it's just n times A, 9 times A. So R must be plus or minus 3. Now we're going to use the fact that the sum of the first 6 terms is k times the sum of the first, the sum of the first 6 terms is k times the sum of the first, 2 terms. So sk is k times s of 2. Now we know for the general rule for s of n is a r to the n minus 1 over r minus 1. So for this is a r to the 6 minus 1 over r minus 1 is equal to k a r squared minus 1 over r minus 1. So k must equal r to the 6 minus 1 over r squared minus 1 by rearranging that. I'm just going to, that looks like it's r times 6. Just make that a bit clearer. Now, when r equals 3, k must equal 91. And when r equals minus 3, k equals 91. Therefore, k is 91. I hope that helps.